Welcome to another video. This time we have a problem related with the normal force on a horizontal surface, and we are doing a case of stacked up objects. So when objects are placed one on top of the other. So for the arrangement of masses at rest, draw the free body diagram for the individual masses. So we have three masses. We have to draw FBD for all of them. And with the condition given, always it will be that ignore the force of gravitation between the masses because it is negligible. And then we have to write a expression in the vector form for the condition of equilibrium. So the objects are at rest, and therefore, as far as the y direction is concerned, we have to write the condition for vertical equilibrium. And then use B to find the normal force on the individual masses. So there will be a normal force on M3, M2, and M1. We have to find the value for that. And finally, what is the net force on the individual masses? So let's dive into it. And also one more important thing, I'm going to apply the concepts which I have explained very clearly in my earlier video given at the bottom. So please feel free to have a look at it for a holistic understanding of the numerical. So for a problem like this, the best and the easiest approach is to start with the object which is on the top. So we have the three objects A, B, and C, which are placed on the ground or earth, which I can call it as maybe object E. And the masses are respectively given as M1, M2, and M3. So we start with the topmost and focus on free body diagram for C. So it is given that all the objects are at rest. Yeah. What are the forces? Now focus only on C and see what are the forces which are acting on the object C. So as you can expect, there is a downward force exerted by Earth on the object C. So the nomenclature is by and on. So which is equal to the weight of the object, which is m3g. Yeah. And since it is given that we have object at rest, so there are no net forces acting on the object in the y direction. Of course, in the x direction also, but we focus on y direction. Yeah. So later in some of the more complex problems, we will be talking about the equilibrium for the x direction also. But in this question, we need to focus only on the y direction because normal forces are always in the y direction. Now, since the object C is not moving, it's not going anywhere. Yeah, it's not sinking into object B, or it's not flying up. It's not leaving the surface with B. So there has to be equal and opposite force acting. So as I've explained in my earlier video also, there will be a normal force by object B on object C. Yeah, and normal force will always be by the object which is in immediate contact with the object that we are discussing. So in this case, it will be always B that will exert a normal force on C. And that has to be equal to m3g because otherwise the two forces will not balance each other. Yeah. So to summarize, in simple terms, the weight of the object acting vertically down will be balanced by the normal force by the object B on object C acting vertically up. So the magnitude will be the same, m3g, and the direction will be opposite of each other. So that's how the object C is in equilibrium. And talking about part B, what's the equation? So as I mentioned, we have to focus only on the y direction. So we talk about the net force in the y direction has to be 0. Yeah, so add up all the forces. They should vectorially sum up to 0. So that means NBC plus FEC should be equal to 0. Now, which means the magnitude of all the vectors acting vertically up will be equal to the magnitude of all the vectors acting vertically down. So which means NBC will be equal to FEC, and that in turn will be equal to M3G. Let's now move quickly to the free body diagram for the object B. So focus only on B and see what are the forces acting on it. First of all, B is not moving anywhere. In fact, none of the object is moving. So right now we are focusing on object B only. Object B is not having any movement in the vertical direction. We have to draw the free body diagram and then find the normal force. And we know that since normal force acts in the vertically up direction, therefore we need to focus only on the vertical equilibrium. So in the x direction, there are no forces acting. You can assume that. Whereas in the y direction, there are a set of forces acting, but the net force on the object B is 0. So let's see what are the forces acting on object B. Let's focus first on what are the downward forces. So there is a force of gravitation by Earth on B. And that is nothing but weight, with which you are already familiar. This time the mass is m2. Therefore, it is m2g. And is there any other downward force acting? Yes, definitely. So there is a force which is a normal force by C on B. Where is it coming from? So it's coming, as I indicated, by C. If you see very carefully, these two are action and reaction pairs. So NBC is by B on C, whereas NCB is by C on B. So to every action, there is an equal and opposite reaction, Newton's third law. And the magnitude of the two forces will be the same, and therefore NCB will be M3G. So we know that there are two forces now acting vertically down on B. So there is a FEB and there is also NCB. And therefore, naturally, there has to be a force acting vertically up on B to ensure the vertical equilibrium. That means there is no net force on the object B. And where will that force come from? There is no other force other than the normal force. So the normal force will always be applied by a surface or an object which is under B. So that is by A on B. And that has to be equal to M2 plus M3G. Only in that case, this object will be in vertical equilibrium. So in terms of the equation, so that remains the same. F net in the y direction will be equal to 0, which means the sum of the three vectors NAB plus FEB plus NCB equal to 0. Now that is possible only when the sum of the magnitude of the forces in the vertical up direction is equal to the sum of the magnitude of the forces in the vertical down direction. So which means NAB will be equal to FEB plus NCB. So there is also a question asked, what is the normal force value? So that we have already indicated in the FBD, that will be equal to M2 plus M3 times G. Let's focus on the free body diagram for A. So focus only on the object A and check what are all the forces acting first in the down direction. So immediately we can see that there will be a force of gravitation by Earth on A, which will be equal to the weight of that object, which is m1g. Is there any other force acting vertically down? So if you see carefully, and also as we know, there will always be a normal force by the object B on the object A. Where is it coming from? So if I can draw, these two are related. So NBA and NAB, they form the action and reaction pair. Okay, they are therefore equal in magnitude. Yeah, so that will be NBA will be equal to M2 plus M3 times G. So we now know there are two forces acting in the vertical down direction. So therefore, and we also know that there has to be an upward force, and that upward force is nothing but the normal force. So there will be a normal force by the ground on the object A. If this object has to be in vertical equilibrium, then that upward force has to be equal to sum of the downward forces, which is m1 plus m2 plus m3 times g. Now, in terms of the equation for equilibrium in the vertical direction, again, the same concept, the net force has to be 0. That means if we do the vector sum of NGA, FEA, and NBA, together they should be 0, which is possible only when the NGA, magnitude of the force in the vertical direction, equal to sum of the magnitude of the forces in the vertical down direction. So therefore, NGA will be equal to FEA plus FBA. Time to summarize the learning. Normal force by an object on the object above will always be equal to the combined weight of the objects above. So what this literally means is, let's quickly write down all the normal forces. So normal force by B on C will be equal to weight of the objects above. So weight of C, yeah. So that will be equal to M3G. And normal force by A on B will be equal to weight of B plus weight of C. That will be equal to M2 plus M3 times G. And normal force by the ground on the object A will be equal to weight of all the objects A and A above. So that will be equal to M1 plus M2 plus M3 times G. Now let's say now the questions could have been asked in very many different ways. So let's say the question asked list down all the action reaction pairs when it comes to normal force. So then it should be very easy. So corresponding to this, there will be a normal force by C on B, which will be because these two are action reaction pair, NBC and NCB are action reaction pair, so magnitude has to be same. Yeah, so M3G. And corresponding to this, if the normal by B on A will be equal to M2 plus M3G. Yeah. And similarly, this will also give normal by A on the ground will be equal to M1 plus M2 plus M3 times G. So these are all, so we will have three pairs of action and reaction forces when it comes to normal forces. So these are all the three pairs I've drawn. Let's say there is a question, draw all the action reaction pairs as concerned with the force of gravity with the individual objects. Yeah. Then it will look something like this. So there will be a force by Earth on object A that will be equal to the weight of the object A that will be equal to m1 times g. And remember that there will also be a action reaction force which is force by A on Earth which will be equal to m1g. And similarly, there will be a force of gravitation by Earth on B, and that will be equal to the weight of B, which is m2g. And of course, as the action reaction pair, it will be complete if I make it equal to FBE. Is there any other force of gravitation? Yes, there is an object C. So there is a force of gravitation by Earth on C, which will be equal to weight of that object, which is m3 times g. And of course, the other force in the action reaction pair will be FCE. So these are the different ways in which the examiner can ask you the questions. Let's say I replace this question with any other shape. Yeah. So here I've taken the rectangular shape. Even if we take any other shape, the concept remains the same. The equations and the forces, they remain the same. So let's put some numbers to complete the numerical. So let's say we have M3 equals to 1 kg. I will not be writing the units, just the number. And M2 is equal to 2 kg and M1 equals to 3 kg. And let's also take G as equal to 10. Okay. So NBC equal to NCB equal to M3G. So which should be 10 Newton. Yeah. NAB equal to NBA should be M2 plus M3. So 1 plus 2, 3. 3 times 10 is 30 Newton. And NGA equal to NAG equal to sum of all the masses, which is 3 plus 3, which is 6 times 10, 60 Newton. And therefore, also from here, FEA equals to FAE equals to M1G. Yeah, so that is 30 Newton. FEB equals to FBE equals to M2G, 2 times 10, which is 20 Newton. And finally, FEC equals to FCE equals to M3G, which will be 1 times 10, which is 10 Newton. So before we close, a note, and that is whenever we are talking about the force of gravitation of Earth, we have always used the letter E, E for Earth, and that's because the force of gravitation is acting towards the center of the Earth. So it's always Earth as a complete object which is exerting that force, and therefore we use force of gravitation with letter E. But when it comes to the normal force by ground, as you already know, the normal force is exerted by the surface in contact. So the object in contact here is Earth, but specific name here, more relevant name will be the ground, and therefore we use the letter G. So normal force with G and gravitation force with E as the source of that force. And why do we use that? This is just to make it very clear in our diagrams, the kind of force we are talking about. Thanks for watching. Please like, subscribe, and share. Please do drop your comments. They definitely help us. Thank you.